So right above those pictures, you already have the word correlation coefficient. A number from -1 to 1 that measures how well a line fits a set of data. When R is near 1, the points lie to a line with a positive slope. When R is negative, line with a negative slope. Where R is 0, the points do not lie close to any line. Give about a minute to copy that puppy down. When we talk about scatter plots, the more the scatter plot gets to the shape of a line, what scientists will call that a strong correlation. That means there's a strong relationship between the two variables. The more scattered they are, the more that scientists will say there's no correlation, there's no relationship between what's on the x-axis and what's on the y-axis. For instance, let me give you an example. Let's pretend we did a scientific study, just a Park West students. Don't write this down. But let's just say I let the y-axis equal to GPA. What is the lowest GPA? 0, huh? Then it goes, was it 1, 2, 3, and 4, huh? 4 is 4.0? And let's say I want to measure Park West students. Again, phone's away right now. Don't write this down. My hypothesis is that the more a Park West student spends on his phone, the lower his GPA is. The more a Park West student spends on his phone, the lower his GPA is, which means the reverse. Less time spends on his phone, the higher GPA. So let's just say I studied 100 Park West students, and every student is a point. So this is a GPA. This would be time on phone per day. Maybe I did it by minutes. 30 minutes, 60 minutes, and so on, right? 120 minutes. I would suspect that if every dot is, so I would look at it, I would study a student and see how long they spend on their phone. What if we had something like this? There's always going to be exceptions. But let's just say that every student that I studied, the longer they spend on their phone, the lower their GPA was. So what we would say is, a scientist would say, well, that's a pretty strong correlation. Correlation means there's a relationship between GPA and time spent on the phone, but there's not a causal relationship. This is not causing the other one. There's a lot of factors that go into GPA, but time spent on phone is one of the factors, but we can't say that time spent on the phone causes GPA to go up or down, but it does play a part. And there is what the scientific word is correlation. There's a relationship going on between phone time and GPA. The longer a student spends on their phone, the lower their GPA tends to be. Now, how strong is that relationship? You may say good. Chavez may say eh. Waters may say good or bad. We don't want it to be an opinion. We want a number, and that's what the correlation coefficient is all about. In other words, the R value. I'm going to show you how to calculate the R value, but for now, right, so look, you got perfect, strong, weak, no correlation. Look, it doesn't approach a line at all. It's all scattered. There's no relationship between those two variables. How about a weak negative, strong negative? Look, it's getting closer to a line, and then perfect negative correlation. So what I want you to do on your notes, go ahead and box -1 and put an arrow from here to this picture. So whenever you get an R value at negative that's getting close to -1, it's getting closer and closer to a strong negative correlation. And then do vice versa for the positive one. the more and more your R value is a positive 1, the more closer it's getting to a positive correlation. The more it gets to 0, the more a scientist will say, you know what, there's no relationship between, let's say, for instance, my study of GPA and time spent on phone. If my scatter plot started looking like this, let's say my scatter plot's something like this, it doesn't seem there's a relationship there. That means the R value is going to be close to 0. See? That means there's no correlation at all. That means there's no relationship between the two variables I'm measuring. Now, I keep saying R value. How do you find the R value? That's the question. In other words, you might be asking, hey, Mungi, let's do the math now. What is this R value you speak of? How do you find it? What's the formula? Well, here's what you do. Check this out. Remember the data from yesterday? We did the line of best fit with this data. Look at how easy R value is. Watch. I don't want you writing anything down. Just watch the master do it. Check it out. I'm going to go straight to my calculator. Remember the linear regression calculator? But let me start over. So I don't want that calculator. Watch. Let me get the link. Look how easy this is. This is so easy, it's scary. Value. I'm going to scroll down. I'm not going to do the linear regression calculator because I'm not looking for the equation of the line. I want the R value. In other words, the correlation coefficient. Look at it. They call it the Pearson correlation coefficient calculator. Let me click on that puppy. So I'm just going to show you how to do it, and then we're done with our notes. Look at it. That's the formula right there. That might give you nightmares if you look at it. But don't worry. We're not going to use this formula. We're going to let the calculator do the work for us. Let me press take me to the calculator. Watch. Look what's asking for now. X values and Y values. You got to be kidding me. You got to be kidding me. Look how easy this is. Watch this. So how strong is there a relationship with this graph? Is that a strong relation? It looks pretty strong. It looks like a strong positive correlation. It looks like a strong positive. Let me get the R value just to make sure it's not up, because I don't want to make it up to opinion. Let's get the R value. Let's make this scientific. Here we go. X values, you got to be kidding me. 1, 1, 3, and so on, right? 4, 4, 5, 6. Look at the Y values. We've got 1, 1, 2, 2, 3, 3, and then a 4. Simple. Look what it says. Did I? You lying. I thought there was 2 1s. My bad. Wasn't there? My bad. 1. Okay, there's 2 1. Good looking out. This is a 2. All right, so look how I'm going to do. Just calculate R. Look at how ridiculously easy this is. Calculate R. There it is. So the R value is 0.9465. Let me copy and paste that. Where does 0.9465 lie on our? Let me paste it right here, see if it comes out. Look at 0.9465. That's positive, so look at, it's close to 1. It's over here, which makes sense. Look at the data. The data kind of looks like a strong positive correlation. In other words, it looks like right over here, strong positive correlation. And so that's why it's close to positive 1. 0.94 is very close to positive 1. The more positive slope, the strong positive correlation. The more negative slope, close to 1, is the more negative correlation. Okay? So what I just did looks like a strong positive, and so I'd say If they ask you how strong is the correlation or is there correlation, the answer would be it's a strong positive correlation because it's close to +1. That's it. I'll talk more about this on Tuesday after we get back from the break. This is not going to be on the quiz tomorrow. What I want you to do now is just do a simple seesaw. The notes you just wrote down, you're going to say something about them on a seesaw, then go on to your assignments. Nothing's due today. 35 was due yesterday. If you want to work on that, if you didn't get that into me, knock yourself out. But 36 and 37, I want you to work on them, but they're not due today. The only thing that's due for your second stamp is a seesaw post. It'll take you less than 3 minutes to finish. Have a great day. Get on your mark, get set, go.